Okay, hi everybody. Welcome back to section 7.3. And in this video, we're going to take a look at the now inverse of the second translation theorem. So we learned about the second translation theorem. We learned about the alternative form, and now we're going to work backwards and find the inverse of it. And this helps us out when we do an initial value problem, but we'll get there in the next uh, video. So let's just learn what the inverse second translation theorem is and how to apply it. So if f of t equals the inverse Laplace of f of s, then the inverse of the second translation theorem is this: inverse Laplace e to the negative as f of s equals f of t minus a times u of t minus a. So shifting a units for the t-axis. So notation's a bit weird. So here's a bit of a checklist that I like to think of when I do these problems. So, I want to identify what a is, what f of s would be, the Laplace transform, and I want to know what the inverse Laplace transform of f of s would be. That would be f of t that we're looking at. So these are three things that I want to know. And then at the end of the problem, we're going to need to plug in t minus a wherever there's a t, because we're shifting a units on that t axis. Okay, so once again, it's symbols and notations a bit weird at first. So let's go ahead and try out a couple examples. So inverse second translation theorem. So we want to find the inverse Laplace of 1 over s minus 4 times e to the negative 2s. Okay, so we're going to use this idea right up here. We want to figure out what a is first. Okay, so right away, I could see that e to the negative 2s, that here, a equals negative 2. Okay, and I can figure out what the Laplace transform is, 1 over s minus 4. So f of s is 1 over s minus 4. And the third thing I want to figure out is, well, what is the inverse Laplace of 1 over s minus 4? So we should be pretty comfortable with this by now. The inverse Laplace of 1 over s minus 4 is e to the 4t. Okay, so this e to the 4t, well, that's actually my f of t. So when we put all these components together, what I end up with is yes, e to the 4t, but remember, we are shifting 2 units to the right. So this would be e to the 4t minus 2, because this is what f of t minus a is. It's my function. A is 2, excuse me, not negative 2, it's regular positive 2. This is what f of t minus a is, times a unit step function of just t minus 2. So you could clean this up if you want, like e to the 4t minus 8 times u to the t minus 2. But that would be our answer. Okay, let's try the next one. Inverse Laplace of s over s squared plus 9 e raised to the negative pi s over 2. So same thing. Identify what a is, identify what f of s is. So pi over 2 would be my a, and then s over s squared plus 9 is my f of s. And so the inverse Laplace of s over s squared plus 9, well, that's going to be cosine, because what is 9? 9 is just 3 squared. So this would be cosine of 3t. And this is my f of t. So when I go ahead and do my inverse Laplace, s over s squared plus 9, e to the negative pi s over 2, what this turns into is cosine 3, but remember, we are shifting pi over 2 units to the right. So this would be 3, not 3t, but 3t minus pi over 2 times a unit step function of t minus pi over 2. And once again, this is like f of t minus a. So I'm inputting t minus a into my function. Wherever t is, plugs in t minus pi over 2. So this is correct. We could clean it up if you want, like cosine of 3t minus 3 pi over 2 times a unit step function, t minus pi over 2. But that's essentially how we would do this problem. Okay, so that's inverse Laplacing with the second translation theorem. Okay, and this would help us out in a specific initial value problem, which we'll see in the next video, specifically piecewise. But that's it for this video. Just a bit of an introduction and practice, and I'll see you in the next video. Okay, take care.